So, ladies and gentlemen, we saw two examples. Ultimately, both the examples were focusing on how to actually finance risk. The goal is, even if you invest on risk reduction, what would be your commitment towards finance, what would be the return, what would be the benefit annually you get from that risk reduction process, and of course, what would be the payback period of your investment. Now, we are interested in looking at a very simple phenomena called how will you defeat an accident process. What are the steps involved in defeating an accident process, what are the desired effects, and what would be the procedure to control them. The steps involved are the following: initiation, propagation, termination. The event that starts the accident is what we call as an initiative accident. Events that expand the accident is propagation, and the events that stop the accident are called termination. The desired effects on the events that would start the accident should be diminishing, and the procedure to control them may be grounding, inerting, maintenance procedure, process design, training to reduce human error. When you look at the propagation, you do not want those events to expand to result in accidents. Therefore, the desired effect I want on propagating events should be diminishing. The procedure to control them are emergency material transfer, less inventory of chemicals to be stored in the working place, use non-flammable construction materials, installation of check and emergency shutdown valves, etc. And the events that stop the accident should be on the increasing side, that is the desired effect I want, and the procedure to control them would be end of pipe control measures, effective firefighting equipments, effective relief systems on board, effective sprinkler systems on board. After understanding how actually you would finance risk, what are the different methods, the fundamental question which you may get in your mind is there anything like acceptable risk? In an offshore industry, can I accept a risk? Because risk is contemporary to safety. Whenever I say I accept a risk, my safety is at question. Ladies and gentlemen, it is very interesting to know that risk is acceptable to regulatory agency and also to public. According to United States EPA criteria, a lifetime risk of 1 in million, that is 1 in 10 power 6, is defined as an acceptable limit for carcinogens. For non-carcinogens, acceptable risk is hazard index of less than 1. According to UK Health and Safety Executive, acceptable fatality accident rate is 1.0. So, all international bodies basically specify an acceptable value of risk. Look at the fatality statistics for a common non-industrial activities. Before understanding what would be such statistics for oil and petroleum industry, let us have a very common example of looking at non-industrial activities. This is suggested by loss prevention given by Frank P. Lees, a Butterworth publication reference. It is a simple table given by Frank saying that interestingly, even staying at home can have an FIR of 3, deaths at 10 power 8 hours. Traveling by car can create an FIR of 57, and rock climbing can be as high as 4000. These are all non-industrial activities, therefore, you will not see any of these numbers related to offshore and petroleum industry. We will talk about that in the coming slides. What I want to apprise from the slide is there is an acceptable level of risk even when you stay at home, that is what Lee has suggested. I would like to just give you a tutorial sheet. Interestingly, can you try to solve these questions which I am posting to you? Remember that the solution of this tutorial sheet is not presented in the presentation here, you have to write your feedback and request for the solution from NPTEL at IIT Madras. Identify major ways to prevent accidents resulting from fire and explosion. There are 3 common systems used as a measure of accidents. Can you name them? Also indicate the most important common feature between the 3 methods. Can you define individual risk and societal risk? What do you understand by acceptable risk? As an employee of an oil industry, how do you react to a term acceptable risk? We have some numerical questions also for you. You are given 2 options to reach station A from station B. You wish to drive the complete distance of 2200 kilometers between A and B by an average speed of 45 km an hour to reach the station by road. Alternatively, you plan to fly and reach the station B by commercial airlines, which will just take 2.5 hours. Now the questions are the following: which travel is the safest? A, traveling by road at a specific speed, B, traveling by airlines a specific time. Amongst these 2, if you have got to travel, which travel is the safest? Remember, you have got to identify your answer based on fatality accident rate in general. Table 3 for different fatality accident rate for different modes of transport is available in the presentation. I will just show you. You have got to also find what is the fatality rate for the safest trip amongst these 2. Now the fatality statistics given for different travel by Frank Lee are the following. So traveling by air has a fatality rate of 240, whereas traveling by car has a rate of only 57. Remember, traveling by cycle also has a fatality accident rate. Suppose you travel by car at an average speed of 60 km an hour, do you think that FAR will change? Because the earlier example said you have to travel by 45 km an hour. Do you think by increasing the speed of the car the fatality accident rate will change? If you feel it is changing, will it increase or decrease? Guess the answer, do not try to work it out again. You should also justify your answer without working out the FAR in detail. I have another question for you. Question number 6. An employee works in a process industry with an FAR of 4.0. This industry has normal working hours. As the employee gained experience in this trade, he wishes to change his job. Another oil and gas company in abroad offered him a job. The work agreement between the employee and the company states that his working hours are only 4 hours per shift and shall have to work only for 200 days in a year. This is a part of the work agreement shown to the employee by the company in advance. Now the process industry and the oil and gas industry has different FARs. For the process industry the FAR is 4, for oil and gas industry I have a table given to you. With reference to that table, you have got to suggest the following. Now the employee is confused. Why? Because the FAR ratio for oil and gas industry is much more than the process industry. The employee is confused because he foresees a higher risk in oil and gas industry compared to the current process industry where he is employed, but he expects a financial gain by shifting his job. Now answer the following. Let us try to again read the problem and understand. An employee works in a process industry, the FAR is 4. He wants to shift his job from this industry to oil and gas company. The FAR for oil and gas company is much more than 4. I have a table which I will show you what is the FAR for oil and gas company. But the working hours of this company is scheduled in the agreement. He has to work only for 4 hours per shift and has to only work for 200 days in a year. The employee is confused because the FAR ratio or the FAR number given for oil and gas company is much more. He foresees a higher risk. Now the employee opts for a change in his job. Should he change the job? You must advise him as an HSE consultant. Explain the basis on which you will work out his safety in the new job. Suppose the employee wants to shift back to his original employer after his abroad assignment is over, can you advise him to bargain towards his working hours so that he faces the same fatality rate as that of his recent abroad assignment? If so, state briefly those lines of advice that you will sketch for him. Now this part is very interesting. The employee changes from FIR 4 to an oil and gas industry. As an HSE consultant, you advise him accordingly, but suddenly after working for some years in the oil and gas industry, the employee wants to get back to the previous job. Now you have got to again advise him accordingly what bargain he should do. He can now do a bargain because he is more experienced. This is a very interesting table given for you, taken from Bob Skelton 1997. For different industry, what are the different FIRs? For example, the employee is now working in a factory which is having an FIR of 4. The employee wants to shift from a factory to an oil and gas industry which is FIR 62, and that is the worry what the employee is having, because his FIR is now moving 15 times ahead. He is worried. As a HSE consultant, tell him should he shift this job or not. The solution for these tutorial sheets are available on request. You have got to write to nptel@iit Madras for requesting the solutions along with the feedback for the problems. Let us look further beyond. I am interested to do what I call as risk assessment. It has got two categories, risk determination and risk evaluation. What do you mean by risk determination? It has got again two branches. First, identify the risk and then estimate. Both of them are called risk determination. In identification, I will observe for new risks or for change in risk parameters already existing. In estimation, I will determine the probability of occurrence of risk and the magnitude of consequences if the risk occurs. Whereas in risk evaluation, I will look for risk aversion or risk acceptance. In risk aversion, I will determine the degree of risk reduction and the degree of risk avoidance, whereas in risk acceptance, I will establish risk references and risk referents. Let us take a specific case for risk assessment. We will consider now a chemical plant which I call as a process industry. The National Academy of Sciences identified 4 steps in chemical risk assessment. I have a separate module where I will explain in detail how to do a chemical risk assessment. In summary, National Academy has identified 4 steps: hazard identification, dose response assessment, exposure assessment and risk characterization. What do you understand by hazard identification? This includes engineering fault assessment. Basically, it is used to evaluate reliability of specific segments of a plant in operation. It determines probabilistic results. The method employed is what we call as fault tree analysis. The dose response assessment, this involves describing quantitative relationship between the amount of exposure and extent of toxic injury. Hazard of material is to be recognized before effects are assessed. Outcome will be a linear equation relating exposure to disease, and the method used is regression analysis of dose response data. The exposure assessment describes nature and size of population exposed to the dose agent, its magnitude and duration of exposure. This assessment shall include analysis of toxicants in air, water or food, and finally the risk characterization is an integration of data and analysis. This determines whether people will experience effects of exposure or not. It includes estimating uncertainties associated with the entire process of risk assessment. Now let us look at some application issues of risk assessment. Risk assessment often relies on inadequate scientific information or lack of data. That is a very serious note. You do not have sufficient scientific information to assess risk, especially on oil and gas industry. For example, any data related to repair may not be useful to assess newly designed equipment. Already we have shortage of data. Even within the data, those related to repair cannot be used for design. It means that even though the data available is less, still all data related to that cannot be considered as qualified data to do risk assessment. Then what do we do? Suppose for example we have enormous amount of irrelevant data, then what do? I can give you a specific quote. In toxicological risk assessment, generally the data related to use of them in animals is considered to predict their effect on human beings. Now one can say the effect of toxicants on animals can be different to that of toxicants on human beings. So one can also say it is an irrelevant data. Then how do we do risk assessment? It is a good question. Do you think that risk assessment is going to be a rigorous mathematics? The answer is yes, but it is very simple and easy because we use probabilistic tools to do that. For using probability, obviously the data size, what we call as ensemble, that is the main issue, but people still do conservative approach to avoid overestimating risk. Others may use comparative techniques with several options, which will be discussed in different modules in the coming lectures. Why the approach is called a conservative approach? Then what is quantitative risk assessment? In quantitative risk assessment, we identify frequency of an event, its severity, then calculate risk rankings, then assign them and plan to reduce risk. This is what we address as risk management. We saw an example of A, B, C, D sections of a plant given by Morgan analysis. We can also use what is called comparison technique. This is what we call as qualitative risk assessment. This is done by conducting a survey. You prepare a series of questionnaire, then do risk rating. You try to understand the plant A's risk compared to plant B. Form series of questions and see whether plant A is relatively safe compared to B. That is what we call as qualitative risk assessment. Now William Fine has given a very good approach for doing this. The reference is given in System Safety Journal 1971. This method is applicable if cost to correct hazard is justified. Remember that in oil and petroleum industry, if you are not able to justify the investment towards risk reduction or hazard mitigation, then no industry will approve your methods of risk reduction at all. William Fine has given a very interesting method to estimate the justification of such investments. This also suggests how quickly hazards should be corrected. This method involves use of risk assessment. Now let us see how to estimate risk score R. The risk score R is actually a product of C, E and P. C is the consequence of rating, E is the exposure value and P is the probability value. Now risk score can be used to decide how quickly to act to correct the hazards. The cost justification is then given by a simple equation which is R by Cf into Dc. R is the risk score which I have already estimated and Cf is the cost factor and Dc is the degree of correction value. Now look at this figure so that we can easily estimate the probability, that is the likelihood that accident sequence will follow to the completion. Now the complete accident sequence can be given a number. For example, if the accident is most likely an expected result, if the hazard even takes place, I give this rank as 10. If practically impossible sequence, I can give the value as 0.1. Look at the exposure part. it is basically covering up the frequency of occurrence of the hazard event. If it is going to continuously occur, then I can give a score of 10. If it is going to remotely occur, I can give a score of 0.5. Look at the rating of the consequences. For example, see in your calculation of analysis, if the consequence is going to be catastrophic, numerous fatalities is going to be expected and the loss is going to be more than 100,000 US dollars, I can give the number as 100. If it is going to cause only a minor injury, then the consequence rank or rating can be simply 1. Look at the cost factor. If the estimated dollar cost of the proposed corrective action is going to exceed 50,000 US dollars, I give a cost factor number as 10. If it is less than 25 US dollars, I can make the cost factor as 0.5. Look at the degree of correction which is required. If the hazard positively eliminated 100%, look and give the rank as 1 or the value as 1. If the slight effect on hazard is going to occur and less than 25%, give the score as 6. If the risk score obtained is between 200 to 1500, then you must recommend immediate correction action, so that the activity should be completely discontinued until the hazard is reduced. If a risk score is lying between 90 to 199, then required attention should be given as soon as possible. If of course the risk score is coming less than or between 0 and 89, then hazard should be eliminated without delay, but situation is not very emergency. So, C, E and P values are selected from the table just now shown to you. Cost justification is then estimated from a simple equation given to you. If the justification is coming to be more than 10, then the cost involvement is justified. This method is used only for guidance. The values given in the table are only indicative. You can also prepare a table of your own choice. One can also prepare such table conducting a periodic survey, but interestingly the method provides a simple way to evaluate variety of hazards to present them to the management. I will take an example of an offshore drilling rig accident. The consequence of such accidents are 100, because when such accidents occur it becomes catastrophic, therefore C is 100. The exposure is 1 because rarely this kind of event occurs. The probability of this accident is 10, because remember that this is not the probability of occurrence of that event, it is the probability of accident if it occurs will follow to completion. Generally all oil rig accidents follow to completion. Therefore, I have given this P number as 10. Now, ladies and gentlemen, you can easily estimate the product of these three, which I call as risk score, which is going to be 1000 for this problem. Now, let us work out cost justification. This is simply given by the equation R divided by Cf into dc. I look for cost factor from the table back again. I put a value 10 here, because the estimated damage level, if at all any such rig accident occur, is very high. I also look at the degree of correction, put the dc value as 6. You may wonder I am giving this very high value, because the corrective measures taken will have very slight effect on such hazards, because all oil rig accidents are really accidents in a strict sense. Whatever corrective measures you take, accidents still do occur. The corrective measures have very light effect on controlling the hazard mitigation. Therefore, I use 6 as my dc. Now, I can easily work out the cost justification, which comes to be 1000 divided by 60, which is the product of Cf in dc, 16.66. Therefore, any mitigation methods suggested to reduce such accidents is more than 10, therefore, the cost involved is justified. Look at the risk score R, which is 1000. This falls between a value of 250 and 1500. It means immediate correction of such accidents are required. This is very alarming, because detailed risk analysis is a mandate for such cases. All offshore industries conduct third party HSE audits once in every year. So, ladies and gentlemen, we had a very explicit presentation on telling you how to assess risk using different techniques. we have solved 3 examples for you. I have left one tutorial sheet for you which is having some objective questions, subjective questions in theory and some example problems to be solved. The answers for tutorial sheets are available to you by request writing to nptel@iit Madras. Kindly give your feedback about the presentation and the lectures what you have heard so far, and if you require any additional value to be added to the presentation or to this lecture, kindly suggest your feedback with your affiliation to nptel@iit Madras. In the next lecture, we are going to look into much more in detail about the risk analysis measurements and methods. Thank you very much.